Hello everyone, in this video we'll try to find a complex number z, but there is if condition here. As you see, if z square plus 1 the whole over d plus I is equal to the magnitude of the modulus of w times z minus 1 over I times the conjugate of w. What's w? It's also given to you here. So first of all, let's find each of them here. The modulus of w and the conjugate of w. Let's find it. The modulus of w means square each of them, the real part and the imaginary part, square them and add in the square root, which is 3 square plus 4 square in the square root. You know, 3 square it's 9 and 4 square is 16. When you add, it's going to be 25. 25 from the square root is going to be 5. This is the modulus of w. The same manner, when we are trying to find the conjugate of w, we are going to negate the imaginary part. It's going to be 3 minus 4i. Originally, w equal to 3 plus 4i. So we need to negate only the imaginary part. So we have these two. And the other thing, d square plus 1, we can write it d square minus I square. You know, I square is the same as negative 1. So negative of negative is going to be plus. So that d plus 1, d square plus 1 is the same as d square minus I square. We can write. This can be factorized and written as z minus I times d plus I. From where you get this factorization process, remember from the square of the difference of the square of two variables, a square minus b square. It is the same as a minus b times a plus b. Don't forget that. So that now when we come back to the given condition, it says d square plus 1. In place we can write this one, the one which is factorized. So it's going to be d minus I times z plus I, the whole over the denominator d plus I we have already, is equal to the modulus of w. We have got it already, 5, which is 5z now we do have here, minus 1 over I times the modulus of w. We got it already, 3 minus 4i. At this point we can simplify here, and then we have left z minus I to the left side is equal to 5z minus, we can rationalize here, we can multiply by I and by I, both the numerator and the denominator. So I times 1, you know, it's I, and I times I, it's going to be negative 1. So negative will be plus here. So this will be plus I in bracket 3 minus 4i. Okay, let's continue to the next page. Let's take everything what we have here to the next page. Then let's complete it. Okay. Therefore, so when we continue, here where we stop. Therefore, d minus I is equal to 5z plus the I will multiply each of them, 3i minus minus is going to be plus, because I times I, you know, it's negative 1. Negative of negative will be plus 4i, just plus 4 only. Therefore let's collect the like term. These two are like terms because they contain same variable z. So it's going to be z minus 5z is equal to this negative I will go and add it. It's going to be 4i plus 4. Therefore the difference here is going to be negative 4z is equal to 4i plus 4. If you divide each of the term by negative 4, then the z value will be, you can make a line, the z value will be negative I minus 1, or we can write it negative 1 minus I, because mostly in case of complex number the real part must be at first and the imaginary part will be the next one. Therefore it can be written negative I minus 1 or negative 1 minus I. This is a complex number z. So once let's repeat the step-by-step process. What did we do here? First we try to find the magnitude of z. Here it is, magnitude of w, which is the modulus of w. We have got it. We'll square every of the real and the imaginary part and add them, then put in the square root. That's going to be 5. And the next step, we'll try to find the conjugate of w, which is, it was 3 plus 4i. The conjugate is going to be 3 minus 4i. Then we try to factorize the numerator here. What do we do? D square plus 1 is the same as d square minus I square. We can do it. Then d square minus I square can be factorized z minus I and d plus I according to the binomial expansion of square of difference. Therefore d minus I and d plus y over d plus I, we do have this one, and d plus I cancelled out and d minus I left to the left side, and to the right side what do we have? 5z left, because the modulus of w is 5 times z. Here it is. How comes this is already 5? And the remaining we try to rationalize this one. We multiply by I and by I both. So I times 1 it's I, and I times I, the denominator is negative 1. So that negative will change this negative. It's going to be plus. And then we go to the next page and we finalize. That's the way how to solve. Thank you for watching.